Hey, this is Mr. Barr, and this is Arithmetic and Geometric Sequences. Actually, it's identifying arithmetic and geometric sequences. So that's what we're going to be doing today. Our learning goal is I can use exponential functions to model real-life situations. Exponential functions show up in science and economics. I want to understand how they are used. Text. Oh my gosh. All right, so it looks like I don't have like a formal introduction for you on this one, and which probably means I don't have formal introductions for the next ones either, but hey, we're going to go on with it. So let's start with our title here, which is we're going to go with identifying sequences. That's going to be our official title for today. So in your notes, let's start with your name, and the title is identifying sequences. I think we're good with the word identifying, hopefully. The word sequence, though, you probably have used this in another context. The idea of what is a sequence. A sequence is a list of things, usually numbers, that are in order. Outside of math, we would think like a sequence of events. Like when you wake up in the morning, there's a sequence that you go through to get ready. You get up, you put on your clothes, you eat breakfast, you brush your teeth. That's a sequence. So for us in math, it's going to be numbers that are in order. A sequence is a list of things, usually numbers, that are in order. This is a mathematical sequence. So numbers in order. So in this case, we have 6, 12, 18, 24, and 30. And you can't see what I'm writing. Numbers in some sort of order. 6, 12, 18, 24, and 30. So this is a sequence. And you've seen sequences in the past, and you can probably figure out what's going to happen next, right? This is plus 6, plus 6, plus 6, plus 6. Each of those numbers is called a term. So we have a total of 5 terms. The value of the first term we call t sub 1. So the value of the first term is 6, and we call that t sub 1 equals 6. This is called t, the letter t, with a subscript of 1 equals 6. T sub 2 equals 12. T sub 5 equals 30. It's pronounced t sub 1. So each number is called a term. For this sequence, the first term, t sub 1, is 6. Here's another sequence. 10, 15, 20, 25, 30, 35. What's happening each time? Actually, I guess I'm not there yet. What is the value of t sub 4? T sub 4 is 25. What term is 35? So this guy right here, what term is that? Is this the first term? Is this t sub 1? No, this is t sub 1. 35 is actually t sub 6. So t sub 1, t sub 2, t sub 3, t sub 4, t sub 5, t sub 6. It's like an address for a house. Who lives at t sub 4? 30 does. Who lives at t sub 3? 20 does. What's the address of 35? T sub 6. There are two main types of sequences. One is called the arithmetic, and the other one's called the geometric. And here's an example of both. We'll get this one into our notes. We're going to call this arithmetic versus geometric. So look at the geometric. What's going on with the geometric? Let's see, 3, 9, 27, 81. It's multiplying by 3 each time. And the arithmetic is going up by 3 each time, plus 3, plus 3, plus 3. On the second geometric, we can see that it's divided by 2, divided by 2, divided by 2. And on the second arithmetic, we see it's subtracting 10, subtracting 10, subtracting 10. So how do I tell them apart? Well, I can see that the geometrics have this constant multiplier. So geometrics are multiplying or dividing. And arithmetics are adding or subtracting. This multiplier is called the common ratio. And for the arithmetic, this adding or subtracting is called the common difference. The common ratio, we use the letter R to describe it, and for the common difference, we use the letter D to describe it. So here's an example geometric. We'll go with 3, 9, 27, 81. And if I do t sub 2, my ratio is going to be t sub 2 over t sub 1, which is 9 over 3, which is 3. So what's going on here? Each time it's going times 3, times 3, times 3, times 3. How do I find that? I find that by taking the second term and dividing it by the first term. And I see that it's 3. Or I take the third term and divide it by the second term. 27 divided by 9 is 3. 81 divided by 27 is 3. The common ratio is 3. When I get into the arithmetic, I have the common difference. And we'll do 3, 6, 9, 12. The difference is t sub 1 minus, t sub 2 minus t sub 1. So in this case, it's 6 minus 3, which is 3. Plus 3, plus 3, plus 3. Second term minus first term. Third term minus second term. 12 minus 9 is 3. 9 minus 6 is 3. 6 minus 3 is 3. Common difference. So if I have a common ratio, I know it's geometric. If I have a common difference, I know it's arithmetic. And with that, I think we can start doing some problems. So right away, I'm looking at this sequence, and I'm trying to decide, is it arithmetic or geometric? And right away, I can see that the common ratio here is 7. It's times 7, times 7, times 7. But if I had a tough time with that, I would kind of show you here. So what's going on right here? 7, right? 7 over 1 is 7. 49 divided by 7 is 7. 343 divided by 49 is 7. It's got a common ratio of 7, which tells me that it's geometric. Okay, let's see what's going on here. This feels like, what's 7 minus 1? 7 minus 1 is 6. What's 13 minus 7? 13 minus 7 is 6. What's 19 minus 13? 6. Oh, it's got a common difference of 6. It's arithmetic. see, ooh, this one's interesting. I might need a calculator for this. Okay, let's start with the common difference. Let's see, 25 minus 16 is 9. 36 minus 25 is 36. That's not 9. That's 11. 49 minus 36 is 13. Huh. Okay, so it doesn't have a common difference. 9, 11, 13 doesn't have a common difference. Let's look at the common ratios. What's 25 over 16? 25 divided by 16 is 1.5625. Let's do 36 over 25. That's 1.44. So this one doesn't have a common difference or a common ratio, which means it is a neither. It's actually kind of a weird thing. It's actually 4 squared, 5 squared, 6 squared, 7 squared. So the next one would be 8 squared and 9 squared. But it's not arithmetic, it's not geometric, it's a neither. I checked the common differences, I checked the common ratios, and I found out that it's a neither. Ooh. Sweet Tom Bakery. So they went from 4 to 12 to 36 to 108. What's going on? Sure looks like it's going times 3, times 3, times 3. That's a geometric. Geometric with a common ratio of 3. All right, let's fill in the missing numbers here. Let's see if we can figure out what's going on with this. All right, looks like it's going plus 3, plus 3, plus 3. So let's go minus 3. 17 minus 3, that would take me to 14. 14 minus 3 would take me to 11. 11 minus 3 would take me to 8. (11 and 14). Fill in the missing number on this one. Let's see. 1 times 6 times 6 times 6. Looks like I've got to do a times 6. 3,888. Whoa! How did I mess that up, man? How did I mess it up? I multiplied it by 3. I should have multiplied it by 6. How about 7,776? 7,776. Excellent. Hey, thank you for watching. Have a good day.